it doesn't look it. There's an airbox, there's an engine, there's an exhaust system, headers, and 2 silencers. That's a bobber style engine, in fact, 2-cylinder. And we're looking at pressure waves in the intake and pressure waves in the exhaust and the tube lengths, and we can set all of that up and develop that, right on the outset. So, as I say, by the time we run bikes, we've got a good idea of how that's going to perform and what it's going to do.
Yeah, so if you've got any younger family members who are thinking of engineering, maths, unfortunately, really does matter. So do point them in that direction.
From that same brochure that you showed earlier,
yeah,
there's
that, believe it or not, is the headstock. So this is where the steering spindle goes through. So if your fuel tank would sit about here, spindle down here, front forks down here. But that was state-of-the-art finite element. And when you compare it to the other images and the work that people do now, it was effectively a 2D calculation, where now you can see that is almost an animated model, a virtual component in full 3 dimensions, where all of the stress analysis is taking place.
Yeah, and we do model the whole of the engine cases, cylinder head, frame. We apply the heat effects onto that, we apply the preloading of the bolts, any interference from bearing shells, everything, and then we can run all of the durability cycles and high-speed cases, and know up front that the parts we've designed are hopefully going to be durable through our testing. We can even look at the pressure distribution across gaskets, so we know, for example, a head gasket is going to seal, or where the weak points are, and where we might want to change that before we cut any metal and start running.
Yeah, and that's obviously engine side. On the chassis side, that same approach to simulation will be predicting what the deflections are of each of the sort of the bars and the castings, and you'll be able to see from the stiffness data that comes back whether it's going to, is it worth taking to a track to actually ride, or is it just going to sort of wobble its way down the runway.
Yeah. We also use that FEA tool the other way. We use it to help guide us in terms of where do we need to strengthen the material, and this is actually an analysis where the computer has run for us and told us that on a balancer, on a 3-cylinder engine, where we don't need metal. So this is the computer optimizing the geometry and saying this would be the lightest design that would give you the stiffness that you need and the strength that you need. The key then for the engineer is to interpret that into something you can actually make. So this is the balancer you would see in a 1200 triple nowadays, the speed triple. I have to move away from using model codes and remember the actual name of the bike.
In design, we don't normally talk about the models by name, they're all code letters. Yeah. So sometimes it takes us a minute to jump between the two.
But this is essentially how we can end up in a situation where successive generations of bike can get lighter and lighter and lighter, and yet be more powerful or better for emissions or so on and so on.
So if this is your first time here at Hinckley, upstairs there is an engine from a speed triple that has been stripped down, and all of the parts are visible on the wall, so you can actually see the individual components. Now, if I think back to some of the earlier generation bikes, if we'd have done the same thing for those bikes, you'd have seen so much more geometric shapes, or basically box-like shapes. But now, because of the tools we've got, and just for being able to draw the things, the CNC machines to be able to machine them in those complex forms, that is how we've taken so much weight out of bikes. It's the ability to take something that is almost a free-form sketch as opposed to a simple to draw cube.
Yeah, a lot more organic shapes. Yeah. Those same sort of plots we showed inside the engine, we do the same sort of analysis outside of the bike as well. We can look at the airflow over a bike, the way that the airflow will trip off a screen, which elements of air approaching the bike are going to get hot. And for example, this is the airflow through a radiator on an earlier generation Tiger. And just looking at the air that goes through the radiator, where does that go? How does that land on the rider's leg? And we can use this up front to go through some iterations again before we ever run a bike, and hopefully get a bit of a feel for where we want to channel that air and what other shapes or fairing or ducting we want to put on the bike.
One of the biggest problems being is, what's the average rider? So
yeah, we've got some extremes. And yeah, again, this just goes to show that every component on a bike is modelled, and those models are used extensively in a number of different analyses. And this being, looking at the pressure distribution from riding the bike and where the pressure is landing on the helmet with different iterations of screen and so on. We also then look at those it's all fluids, so whether it's a gas or a liquid, essentially it's fluid flow. So this is doing the same thing inside the engine, looking at where the engine cooling will go as it travels through a cylinder head on a Bonneville, and making sure we've got effective cooling around the engine, and we've designed the water channels to be the right size. We can then get distribution plots of where the flows are. We can look at the sort of pressure of the coolant through the engine, and we can even then map the heat of that. Sort of, is it taking away the heat that we need from the right areas of the head? Do we end up with hot spots, cold spots? Again, all validated later by actually running the engines and measuring these temperatures and making sure our assumptions are correct, but putting us hopefully in a position where we're a lot closer to the final design when we start running the bikes.
Yeah, there's also a very similar technology to this, which is more biased towards the manufacturing side. So castings, forgings, press work, sheet metal. But you can use simulations, so not too dissimilar to this, as if we're designing a casting and we want to know that liquid aluminium will flow into the mould and it won't start solidifying before it's completely filled the cavity. Very, very similar type approach of software. It's a different brand software, but it's very, very similar approach where it's actually mapping all of that temperature as that liquid aluminium travels through the mould cavity.
If you do the factory tour, I think there is a crankcase section where they show a simulation of that and the metal flowing through the tool. Yeah. And on the simulation it looks like this. And I think it doesn't do justice, because if you actually know how a high pressure die cast machine works, the flow of that hot aluminium that's at what, sort of 500 or 600 degrees, it fills the whole crankcase cavity in about 0.1 of a second. Yeah. So it's not a flow, it's more like a punch.
And when we talk about the tooling, for one half of the crankcase, the tool would fill this stage.
Yeah.
So it's not something you'd quickly take off a machine and put onto a workbench and sort of get the Dremel to very easily, because it's a sort of couple of cubic meters of steel.
Yeah. It's really worth stressing that all of this is to try and help make sure we're developing the right product as early on as we can in the process. Yeah. None of this can replace actually riding the bikes and doing the testing. So there's a couple of photos here that would not normally leave our sort of development files, as it were. This is before releasing the water-cooled Bonneville generation that we released in 2016. And we were doing all of this analysis on will it cool, have we got the water channels right. We took the previous generation of air-cooled Bonneville, we fitted custom-built water-cooled heads and barrels to it, and we actually did the tests as well. So this is all about getting confidence as early as we can in that process. This is obviously, there are no other, as far as I'm aware, water-cooled, air-cooled bikes.
It really does end up with some very, very strange-looking Frankenstein bikes that are around the building at any time.
I think the best one for that as an illustration is upstairs. If you get the chance to have a look, you'll see this bike here. And it was early in the days of trying to work out what we were going to do for the Rocket 3, the next generation Rocket 3. And we needed a mule bike, something we could start testing chassis geometry and sensitivities on. And we needed an engine that was going to deliver the right amount of traction for that. And we hadn't yet designed a 2.5 litre engine power plant to put in it. So that has got a Tiger 1200 3-cylinder engine in it with suitable gearing. And again, it's just to sort of test the theory, test the practicalities of it.
If I remember right, Rob, when they were actually running it on the track, there were some lead blocks somewhere along the way as well to ballast it up as well.
Yeah, but that's just upstairs, so you can kind of see the extent we'll go to actually run this. So I think that brings us on to testing, really.
We're really, really advanced testing technologies now. This is 1990, so those two bikes, I wouldn't be able to tell you which way around they are, but one of them is a 4-cylinder 1200, the other one is a 3-cylinder 750, and we've essentially at that time of the life of the company, we were finding our way and writing our own test standards. And that was the first time that we ever went out and did track endurance. And track endurance is a really core part of what we do with every bike now, isn't it?
Yeah, every bike.
And yeah, some faces that you may So Keith Ewan, he does a lot of the Sky Sports type. So those 4 guys, they took those bikes, and I think we were going for something like a month, just round and round. That was Bruntingthorpe Aerodrome, which unfortunately you can't use anymore, but over towards Lutterworth. And it is very cold, it is very windy, and it is completely bleak. And I spent months of my life there in the early 90s, supporting the bikes. And if you can just see, strange sort of anecdote, very, very large yellow Mercedes van that we used to put all the bikes in. I think we could get about 4 or 5 bikes in the van. Early, 1990, obviously it was just before the first Gulf War, and it was an airfield, so there was no height restriction. The number of times we got fake bombed by tornadoes is unbelievable. They came screaming across. As soon as they hit the what was the sort of perimeter of the airfield, they could come down to 0 feet. Lo and behold, at the crossover point in the middle of the runway, a big yellow Mercedes van. Yeah, we were the target, and I'm probably one of the most bombed people in the UK nowadays.
Well, in fairness, only 2 years ago I had to pull off the track at Sywell for the Spitfire to land.
That's
So,
cool.
that was pretty fun.
That is cool.
Yeah, in the same way of saying you're not allowed to say that people have got it easy these days, we tend to do all of this work at a circuit in Spain now, more for the consistency of weather.
Absolutely. The times, some of the reason why this took so many months to do is you can't do that type of riding when it's wet. It's just not right for the riders. And hence going to Spain, as Rob says, we just get more riding days and more reliability about when we'll be able to finish the testing.
Yeah. This is, you'll recognise, it is not a Triumph. This is, again, the sort of level we would go to then and now. So this is where we've taken a competitor's bike and we will test it, analyse it. We might look at how we would change it and do that work. But this sort of wind tunnel testing, we do even to this day. And what you can see there is a big bundle of wires coming off the bike, which is basically all the data logging from all the different areas around the bike that we're recording temperature. This is in a climatic wind tunnel, actually just down the road at Myra. We're controlling the temperature, we're controlling the humidity. We're running at quite uncomfortable warm temperatures, and we've even been using at times water-cooled suits and balaclavas inside helmets to keep the riders comfortable enough to ride for sustained periods in these environments. That's how harsh it is.
What you can't see on that, and Rob's right, down at Myra, it's phenomenal. You can take a bus into that, can't you?
Yeah.
It's big enough to take a whole bus, and they can take the chamber up to about 45 degrees and down to about -30. And depending on what test you're doing, you can pay your money to Myra and dial it up, dial it down.
Yeah. Again at Myra on the left-hand side, the pave track. I think described like trying to ride down a ploughed road.
One word, painful. I've done that once, and I found reasons every other time not to do that because it is pretty uncomfortable.
It's brutal. And again, every bike will go through that. But obviously we've moved on now and we have to change our test facilities to suit the products that we're doing as well. So there's a shot here, an aerial photo. It doesn't look very clear, but this is our testing facility that we've got in the US for the motocross bikes, part of the race program that we run out there. And you can see where they've made courses up, and they will reconfigure this whole circuit and track to represent different conditions, different circuits we're going to race at.
That's been a heck of a learning experience, hasn't it, with all of the, well, you don't see a rocket doing that. So we've had to learn all over again, new tests, and we're keeping on developing all of those, our own internal standards of what we want, what we aspire to.
Yeah, and there are points on here where, although we've each given examples of when we've ridden, there's some things that we won't quite recreate ourselves.
That is not me. I don't think that, you could offer me an awful lot of money and I would not be talented enough to do that, so that we've got some very, very special riders.
We have, yeah. However, we do ride the bikes. We've said all along, all of this work that we do, all the analysis, the simulation, the engineering and so on, is we're not designing a series of components, we're designing a bike, and the end result is we have to ride that bike and judge it on the sort of premise as a bike of a whole. Yeah. So
one of the really big important things that we try and keep talking to the design teams about is, yes, it might be a fabulous design and a fabulous component, but what does the whole look like? Yeah, it's how the bike rides, how people feel riding the bike, the confidence it gives to the riders.
Yeah.
That's a very important thing, and it's ever so difficult to write down. How do you write down your little widget that you're designing is going to give confidence when it's part of a very large assembly?
Yeah. It's one of the reasons why my role exists. There's four of me in the design department, and each of us owns a vehicle group, so a quarter of the bike range that we do, and our aim is to keep the whole of the project, so that's engine design team, chassis design teams, whoever it is, electrical team, focused around the fact that we're designing a bike, we're designing a product, and it's for a customer. Mm-hmm. It's about the sort of vehicle centricity. And with an office full of, say 580 people, that's how we still try and deliver the focus. That's why that role exists. That is me. That was taken from our Wales Adventure Centre on an extremely wet, i.e. typical day, a couple of years ago.
And that is me at our Wales Centre, and you'll notice I had the foresight to book it when it was blue skies, not like Rob. There had been rain before, as you can see from the puddle. Unapologetic sales pitch. Even if you're a through and through road rider, the instructors at that place are phenomenal, and they will give you the confidence to find what bikes can do and the technologies on the bikes. So the first time I went down there, I was riding a Tiger 900, and it's a gravel path through a forest path, forest track, just gravel. And the instructor says, right, okay, I want you to do this, and then he did it. And basically what it was is riding the bike down on this gravel path, and then he said, just grab the front brake. Now, all of my life riding bikes is, I'm not doing that. Everybody else who was with me, so it was a public day, so non-Triumph staff, we all looked at each other and went, nah, we're not doing that. And we all went out, we tickled the brake, got shouted at by the instructor, went round and did it again. I think it was probably about on my fourth go, I built up enough confidence to do it, and it is extraordinary. The bike just says, fine, leave it to me, stops on gravel. And yeah, it's really surprising, it's an amazing experience.
Yeah. And really just a photo to finish on, because that was my bike when I owned it, and just on my commute to work. I think it just goes to show this is what we do, this is how our design department works. The staff are super passionate about the products that we do. And so all of that analysis, the simulation, the maths and everything else, it's not cold and divorced from the product, it's there to try and make the product as good as it can be and backed up by the riding.
And I think I have to give a shout out for all of the other departments around as well. It's not just the design team that make these bikes. We work hand in hand with the manufacturing teams, with the purchasing teams, and through them to the supplier base. Because it's no good as drawing something that in theory is a brilliant idea. It's got to be of a design that is reliably manufacturable, not once, but 10,000 times over. And there's a lot of time and attention goes into those, and there can be some quite heated arguments. Looking at a couple of gents at the back of the room who are normally doing the arguing. But it's not just about all of the maths on the screen. Yes, we've got to achieve to that level, but we've also got to do it to a level that people can actually make the parts, not once in a race workshop, but 10,000 times over, and that is quite difficult in itself.
Okay. Thank you very much for your attention.
Thank you very much for being here, and enjoy the rest of the day.
Thank you.